Okay, so this is a lesson on chords and arcs and circles. So we're gonna learn the properties of chords and arcs and learn how to apply them. Okay, so first of all, what is a chord? Well, a chord, if you look at these pictures here, you'll notice the pictures on the top, all are in a circle and their endpoints are on the circle. So really that's the key, is it's a segment that's inside a circle, but the endpoints lie on the circle. And so these are examples of things that are not chords. Like a radius is not a chord. One of its endpoints is in the center, not on the circle. So that's the difference. So definition of a chord, a segment inside a circle with endpoints on the circle. Okay. All right, so chords have some properties, and they're related to arcs. And you know what an arc is, right? A part of a circle, so like this part is an arc. We've talked about that before. So we're just gonna get all of our chord properties in right now. And a couple of quick notes before we do that. Just a reminder that this means if and only if. So this is like an if-then statement that can work both ways in either order. So, okay, so this first property says two chords are congruent if and only if their corresponding arcs are congruent. Okay, so if we look at this picture here, let's say I'm going to use my highlighter maybe. Okay, so this chord right here, AB, okay? And then this chord right here, right there, CD or DC, however you want to say it, those are congruent if their corresponding arcs are congruent. So if this arc is congruent to this arc, then those chords are congruent, and vice versa. So if you know that the arcs are congruent, then the chords have to be congruent. So it goes both ways, which is why we have the arrow in the middle, which stands for if and only if going in both directions. So that's an important thing. So we're going to say that, and let's write it right here. So this is a segment AB. The length of that is equal to the length of CD in this picture. So AB is congruent to CD, or the measure of AB is equal to the measure of CD if the arcs are congruent, their corresponding arcs are congruent. So that would be the measure of arc AB is equal to the measure of arc CD. Okay, so what we just talked about. And again, if you know that the arcs are congruent, then the chords have to be congruent. So it also works the other way. So that's important to note, and as is the case for all three of these properties. Okay, the next one says two chords are congruent if and only if they are equidistant from the center. In other words, the same distance from the center. So in this, we'll go back to our highlighter maybe. This segment and this segment, those chords, are congruent if they are the same distance from the inside. So let's maybe we'll use this. If this segment to this segment, right, this distance here and this distance are the same, then the chords have to be the same, okay? And then if the chords are the same, then the distance in between has to be the same. So both ways. So let's write out what that means. Okay, so this would be AB equals CD again. If and only if segment EF, the length of EF is equal to the length of EG. Okay, so again, just talking about the distance on the inside. All right, so that hammers that home. And then the last one, which is pretty important as well, is a diameter or a radius is perpendicular to a chord if and only if it bisects the chord and its arc. Okay, so there's a whole lot going on there. Let me erase this stuff here so we can talk about what we have here. Okay. So a diameter or a radius is perpendicular to a chord if it bisects it. Okay, so I have that. Let's just say this radius right here. Okay, that is perpendicular to this chord. It's perpendicular if it bisects the chord and its arc. So meaning if this segment and this segment are the same and this arc and this arc are the same. And then again, vice versa. So if you know that this arc is congruent to this arc, then you know that this radius is perpendicular to this chord. So that's kind of an interesting thing to think about, but we're gonna write that out then down here. So this let's say EH, maybe we'll do the one up top, EH, okay, is perpendicular to segment AB, okay, if and only if AF, that segment, is congruent to that segment. So AF the length of AF equals the length of, let's do BF. And I'm going to write another one. And the arc, the measure of arc AH is equal to the measure of arc HB. Okay? So that this and this then are the same. And again, this works both ways. So if you know that, then you know they're perpendicular. So just keep all of those properties in mind as we go through and apply these properties now. Okay, here we go. Let's look at these. We have 3 problems here. Let's just find x. Okay, so we know first that this is congruent to this. So that means this, maybe change colors. Let's do that. That means this arc has to be congruent to this arc. Okay, that's one of our properties. So we can say 7x plus 24 equals 115. Okay, subtract 24. We just solve this for x. We get 7x equals 91. Divide by 7. Ooh, there's a better 7. Divide by 7. So x equals 13. Okay. So just using that property to help us. Okay. Let's try another one. Find the length of x, y. Okay. So this time you're given that the arc is the same. So this arc is congruent to this arc, which means then that this segment has to be congruent to this segment. Okay, so I can write that. Okay, so 9x minus 34 is equal to 4x plus 1. And now we just solve. So get all our x's on one side. 5x minus 34 equals 1. Add 34 to both sides. Okay, so 5x equals 35, and then divide by 5. Okay, so we get x equals 7, but it asks for the length of xy. So now we want to apply that. So xy is 4x plus 1. So we're going to say 4 times 7 plus 1, which is 28 plus 1. So the length of xy is 29. Okay. All right. Let's try this one. A little bit trickier. So I know the two chords are congruent. Okay, so this is congruent to this. Cool. That means this arc has to be equal to this arc. Okay, so first, I don't know what those arcs, but I do know that it's all the way around a circle is 360 degrees. So if I go 360 minus 76, whoop. All right, let's try that again. Minus 76, that's going to give me 284 degrees. Okay, so that yellow arc that I just made there is 284. But I only want part of that, so I can just cut that in half. So I'm going to divide that by 2, and that's going to give me 142 degrees. So this is 142 degrees, and so is this section here, 142 degrees. Okay, so now if I want to solve for x, I can just say 6x minus 20 equals 142 degrees, and then we just solve. Okay, so I get 6x equals 162. We're solving for x here, so just doing that, and that is 27. Okay. All right, so that is how you start using some of those properties. We're going to do a couple of more examples to just make sure that we understand all of these properties and how they work. Okay. Okay. All right, find it says DE is equal to 11x plus 15. I think that's supposed to say if DE is 11x plus 15, FG is 3x minus 27, find DE. All right, so the length of DE is this one. So that is 11x plus 15. And FG is 32x minus 27. Okay, so this time I know, you can see on the inside there, this and this are congruent. They're equidistant from the center, these two chords are. So that means that the two chords have to be congruent. So I can say that's using that second property that we had. So let's do that. Here we go. 11x plus 15 is equal to 32x minus 27. And I'm going to subtract 11x from both sides. Okay, and then add 27. 42. And then that's going to give me 2. Okay. Now I need to find DE. Okay. So DE is equal to 11 times 2 plus 15. So that's 22 plus 15. So the length of DE is 37. Okay. All right, so using that second property. Okay, wow, we got a lot more going on in this. It says in circle Z, if the length of RS is 18 and the measure of arc TY is 42, find all the measures over there on the right. Okay, so let's write what we got. So RS, right here, this distance there is 18. Okay. Now, I also know that the other part of this is the measure of TY is 42. So this is 42 degrees. Okay. Now, I notice a couple of things here. So this segment right here is perpendicular to the radius right here. Okay? So if it's perpendicular, right, then we know a couple of things. Then it bisects the chord and its arc. So that means this is congruent to this. It also means that this is congruent to this, which is going to be the same over here on this side. Okay. Cool, because remember, they're all the same. So if RS is 18, then I know that this is 9, and so is this, which makes this 9 and this 9. Okay. All right. Now, I also know that if this arc here, TY, is 42, then that means this has to be 42 degrees, and so is this, and so is this. Okay, so that's just using the properties. Now, is there anything we're missing? All right, TV, let's see. TV, we have, that's 9, okay. TU, that's all the way across. 9 and 9 is 18. WS, also 9. The measure of arc YU. Okay, so YU is 42 degrees. And then the measure of arc RS. Well, 42 plus 42, it's this whole segment right there, right? Or arc. So I want that whole thing, that's 42 plus 42, which would be 84 degrees. And we did it. So just using those properties to help us out. Okay, I have one last problem that I'd like to go over. Okay, it says if the measure of arc CI is 7x minus 15. So I'm going to write that. That's 7x minus 15 right here. Okay, so that's just this right here, right? And the measure of arc EF, which is the whole thing, okay? And that is 12x minus 8, okay? Find the measure of arc CI. Okay, well, on the one side of this, I know that the two arcs, if I went arc DC, so if I went from here to here, that would be the same as E to F, right? But I only have half of that. So I'm going to have to double 7x minus 15, okay? And I remember these are the same because I have the information that it bisects. It's perpendicular, so it bisects, right? So those are the same. So I'm going to double 7x. I'm going to do 2 of those because the other side would be the same over here, right? And that's going to be equal to the full arc EF, which is 12x minus 8. So really, once I have that done, I should be good. So I'm going to distribute the 2. I get 14x minus 30 equals 12x minus 8. And now I can solve. All right, 2x minus 30 equals -8. Okay. All right, so divide by 2, I get 11. Okay. And then I need the measure of arc CI. So let's do it. That's 7 times 11 and then minus 15, which is going to give me 77 minus 15, which would be 62, and then it's degrees. And there we go. So just using those properties to set them up, and then it's just a lot of algebra. Okay, that is it. You can go ahead and try this assignment and put it into your planner. All right, good.